Hello everyone, we are the 12th group of L division and our topic is cache memory. The points to be discussed in this video are what is a cache memory, its importance, different levels of cache memory, its mapping and applications. Myself Ayush More. So the basic and most important question is what is a cache memory? Cache memory is a small sized memory. It is a type of volatile computer memory that provides high speed data access to a processor. It also stores frequently used computer programs, applications, and data to improve overall performance of the computer. Cache memory makes data retrieving easier and more efficient. It acts as a buffer between RAM and the CPU. The next is block diagram of cache memory. As we can see, cache memory lies on the path between the CPU and the main memory. It also facilitates the transfer of data between the processor and the main memory at the speed of the processor. Data is transferred in the form of the words between the cache memory and the CPU, and from cache memory to the main memory, the data is transferred in the form of blocks. Thank you. The next part, which is the importance of cache memory, will be explained by Deepak.
Hello everyone, my name is Deepak More. So, as we see earlier, what is cache memory and about this diagram, block diagram of cache memory. Now we see the importance of cache memory. Cache memory is used to store frequently used data or instructions in order to reduce access time. It's a very fast memory as compared to main memory. It's reduced the average time taken to access data from the main memory. It also helps to improve the performance of the system, increases the speed of the processor by providing data or instructions quickly, helps to reduce the number of main memory access required to execute a program, also enables higher processor speeds without increasing the main memory access time. Also, it helps to reduce the system bottleneck problems.
Hello everyone, my name is Rudra Mondal and I will be explaining the different levels of cache memory. Now cache memory is organized into four different levels: L1, L2, L3 and L4. Let's take a look at each of them. Level 1 cache or primary cache is the smallest and fastest level of cache memory, ranging from 2 to 64 kilobytes in size. It is responsible for providing the CPU with the most frequently used data and instructions. It is located on the processor chip. In multi-core CPUs, a separate L1 cache is available for each core. Next we have the L2 cache. The L2 cache or secondary cache operates at a slower speed than the L1 cache, but has a higher capacity than it. Its size ranges from 256 to 512 kilobytes. It is located on the processor chip or on the motherboard. It acts as secondary cache memory and stores data that is less frequently accessed than that in L1. Next we have the L3 cache. The L3 cache or the tertiary cache is slower than L1 and L2 but larger than them, typically around 1 to 8 megabytes in size. It has twice the speed of the RAM. It is usually found on the motherboard. In multi-core processors, each core may have separate L1 and L2 caches, but all the cores share a common L3 cache. Finally, we have the L4 cache. Now, this is the newest level of cache memory that is becoming more common in high-end processors. It is the largest and slowest level of cache memory. It is located outside the processor and is used to store the data and instructions that are used very infrequently but are still needed by the processor. Next, you will learn about mapping in cache memory, which will be explained by Monish.
Hello everyone, my name is Monish Wadile. So as we have seen cache memory, its different levels. Now we are going to see mapping of cache memory. The mapping of cache memory is the process deciding which data should be stored in the cache and how it should be mapped. There are basically three types of mapping. It's a first one is direct mapping, second one is associative mapping, and third one is set associative mapping. See what are they basically. The first is direct mapping. Direct mapping is a simple way of snapping data from main memory to cache, which can improve performance. However, it is limited as only one block of main memory can be mapped to a particular cache line. Second one is associative mapping. Associative mapping is a type of a memory mapping that allow any word to be stored anywhere in the cache memory, making it fastest and more flexible form of mapping. It is stored in an associative memory and does not have any index bits, and the tag consists of all the remaining bits. The third one is set associative mapping. The set associative mapping is a type of cache memory mapping which combines the fast access of direct mapping with the flexibility of associative mapping. It uses an index address to map a word in a cache to two or more words in the main memory, as it made up sets containing multiple lines. The next will be explained by
Hello
Sandesh.
everyone, myself Sandesh Moralwar. I will be explaining the application of cache memory. First of all, cache memory can be used in the ways browsers to store commonly visited web pages and decreasing the time and data needed for the access them. Next part is cache memories can also be used in the storage devices such as hard disks to reduce the time taken to access the data from the disk. Third point is cache memories can also be used in video game consoles to reduce the time taken to load textures and other game objects into main memory. Fourth point is cache memory is used to store data and instruction used by applications such as the databases, web servers, and media players. Fifth last point is overall the cache memory is an important component of the computer system that helps improve the performance of application, reduce latency, and reduce power of consumption.